Tumtum. Okay, fine. Yeah. So actually, I think you have missed one or two sessions where we discussed about the parts of Arduino module. Uh, we discussed about microcontroller architecture, right? So we discussed many things about Arduino. So today, actually, we are discussing about uh, wire library. I think it's a third session. Maybe in the first two sessions we discussed about different parts, 80 mega 328p microcontroller and different kinds of ports that Arduino is having around 14 digital IO pins and 6 analog pins starting from A0 to A6. And we discussed about communication protocols like I2C communication. So you have any idea about Sumto? You have any idea about I2C communication? No idea. So what kind of sensors have you used before? There are multiple sensors, right? Like a barometric pressure sensor, different kinds of sensors. So with Arduino, have you used any kinds of sensor? You remember any kind of any such sensor? Oh, got it. So you worked on the very first example, blinking of an LED, right? So actually, we are done with that session, blinking of an LED. We are done with that session. So I'll show you that. So whenever we start with Arduino, the first project that everyone usually teaches blinking of an LED. So this is the last project. We have already discussed the code, how it works, and the wiring connections. So we discussed about that. And today we will be actually discussing about this one. So we already done with the blinking of an LED. So today we'll be already we started a discussion yesterday about 16 into 2 parallel LCD display. So recordings are available. So I request one of our team. I will right after the session they will send you the recordings. So recordings are available in the YouTube playlist. So they will share you the link. So kindly whenever you are free, just go through the recording. Right? Is that clear, Somto? Yeah. So if you have any questions after watching the recording, you can feel free to connect with me. You can share your queries maybe in the group or else as a DM. So we will give you the reply at as fast as possible. Yeah. Yeah. So let's continue the discussion from where we stopped yesterday. So yesterday we discussed about wire library and liquid crystal library, right? So with the help of wire and liquid crystal library, we are able to with the help of I2C communication, we can transmit the data and we can display whatever the text that we want, we can display it in the LCD display, as you can see, hello world. So if you want to print your name, you can also print your name as well. So let's say I will try to print instead of I2C LCD display, I will print Somto. I just don't know if spelling is correct or not. Let me check. I think yeah. So Control S and then go to simulation. As you can see now, it is displaying your name. So this is the program to display any kind of text or any kind of characters, ASCII characters. So ASCII refers to American Standard for Information Interchange. So we'll discuss how to convert these characters. There's lots of science behind this. We will be discussing in the upcoming session. So basically yesterday we discussed about wire library and liquid crystal library. Okay, you're not able to see my screen. Yeah, sorry. Yeah, I think now my screen is visible, right? Yeah. So yesterday we already discussed about something like as you can see, something like this, blinking of an LED. So we have uh, you know we have blinked these two LEDs at two different intervals. So today we started discussion on how to display some text in 16 into 2 LCD display. So this is the code behind that. So yesterday we discussed basics about these libraries. So wire.h library, liquid crystal library. So with the help of these two libraries, we can print some data. Okay, we can transmit whatever data that we want to appear on 16 into 2 parallel LCD. We can display it. As you can see now, I'm displaying the name Sumto. So if you want to display some other name like Suchana, welcome to Suchana. So we can display that. So basically, this liquid crystal underscore I square C library. So it provides some basic functions like lcd.begin. So here there are two parameters. The first one is the number of columns, and this is the number of rows. If you just observe this LCD display, so it is having total 16 columns and 2 rows. So different LCD modules may have different kinds of columns and rows. I will show you few of them. So if you just type LCD, there will see. So there are different kinds of versions. So we are having organic OLED display, organic LED display. So we'll be working on all these kind of LCD modules. Okay, LCD and LED modules. If you take let's say some other different version. So this is maybe a different version. It may having different number of rows and columns. So whenever you are using any LCD module, the first thing you need to understand is how many rows and how many columns it is having. You can easily understand by observing these kind of square kind of boxes on the screen. So right now it is having 16 columns and 2 rows. So that you need to pass it to the begin function, lcd.begin function. So then we are having lcd.backlight. So backlight is something like other than text, there would be a backlight. Okay, when I'm just running the program, here you can see. Uh, See, first the backlight has enabled, right? The backlight. Then after the text is being shown on the LCD display. So because we have first enabled the backlight. So whenever you just write this particular line of code, lcd.backlight, immediately the backlight would get turned on. Okay, so this is the function. This is the code for turning on the backlight. And then there is one more function called set cursor. So set cursor function is used to uh, set the positioning from which particular position the text should start getting printed on the LCD display. Okay, so this is let's say if you want to print some text on the first line, then you need to pass 0 comma 0. Okay, so if you want to print some text on the second line, you need to pass 0 comma 1. Similarly for third line, 0 comma 2. So basically 0 comma n minus 1. So you need to set the cursor position 0 comma n minus 1. Okay, so this is a set cursor function. So now I want to print this hello world function. I mean hello world text on the first line. So that's why I'm using lcd.set cursor for which I'm passing 0 comma 0. So that's why it is being printed on the first line. So if you pass 0 comma 1, whatever that I'm gonna write over here, that will be printed in the second line. So let's say I'm just typing Suchana. So here instead of hello world, I'm just typing welcome to. So don't worry guys, we will be also working on this practically with the help of real modules as well. So initially for first few weeks, we will be working on simulation mode. Then after you can start working on practically. Welcome to Suchana. So this is how you need to print some text. Okay. So with the help of liquid crystal underscore I square C library. Okay. So this liquid crystal I2C library depends on wire.h library. So yesterday we also discussed that even without liquid crystal I2C library, only with the help of wire library also we can print some text. So without taking help of liquid crystal library, only with the help of wire library also we can print the text. So then why liquid crystal library is being used? So there's a discussion yesterday that wire.h library. So if you want to directly use wire.h library, then the code would be little bit long. Okay, so it is very complicated and sophisticated that all the people may not able to understand what are the internal functions, how the data is being transmitted. So whenever you are printing some text, So the whatever the program that we are uploading into the Arduino Uno, that is being stored inside the memory unit. We already discussed where exactly the memory, where different kinds of I mean partitions in memory. Okay, we discussed about SRAM, EPRAM, and then we discussed about flash memory or else a program memory unit. So how these instructions are getting executed. So all these things we discussed in the earlier session where we explained about 80 mega 328p microcontroller. So this is the 80 mega 320p 80 mega 328p microcontroller, and we discussed about different parts. Okay, and we discussed about whatever, here we are having a symbol right on the Arduino Uno module. So whatever the pins which is having this symbol, we call them as the progressive with modulation pins. Okay, so we discussed about all these things, and we are also done with one example of blinking an LED. So today we are continuing the discussion. So yesterday we have shown one example how to transmit the data only with the wire.h library without taking help of liquid crystal library. So if you want to do any kind of simulation, you need to use this website app.circuit designer. You can simply search for circuit designer, you will get it. So this is the first one. You can use this website for doing simulations. So you can click on launch circuit designer, and then you need to have an account. First you need to create a new account and then log in with your credentials. Then you can start working on whatever projects that you want. You can click on start from scratch. Then this window will appear. Here you can select whatever the components that you want. Okay, these all are readily available for simulation purposes. So you can simulate all these things. Now am I audible?
Yeah, now we can hear you. Yes, yes.
Okay. So I thought, okay, I'll repeat again. Yeah. Now I'm audible, right? Okay, fine. So yesterday we discussed about wire.h library and liquid crystal library. So liquid crystal, can you just tell me, Mihir, what's the last thing that you are able to hear? Okay, okay. No issues. I'll repeat again. Okay, fine. So yesterday we discussed about wire.h library and liquid crystal library. So yesterday we discussed about these libraries and we understood that liquid crystal library uses wire.h library. So whenever see whatever the components which are connected to the Arduino, they are called as slaves, and Arduino is the master. Okay, all other components which are connected to the Arduino, they are called as slaves. So between any sensor and Arduino module, okay, between master and slave, there always exists a bidirectional communication protocol, bidirectional communication channel, okay, through which both can interchange, exchange information. Arduino, can send instructions, and whatever the module which is connected to Arduino, can also return some readings. If you are using some sensor, there are different kinds of sensors, right? Barometric pressure sensor, temperature sensors, gyroscopes. So those modules can also send the information back to the Arduino, through the bidirectional communication channel network. We call it as the data bus. Okay. Technically, we call it as the data bus. So this wire.h library is used to enable this data transmission. With the help of wire.h library, we can send any kind of instruction to any sensor which is connected to the Arduino Uno. So that is the main library through which we can do whatever data transmissions that we want. If you want to send any instruction to the sensor, let's say you have a temperature sensor connected with your Arduino module, and you want to ask the temperature sensor what's the current room temperature. So you need to pass certain instructions which we call it as registers. Okay, so there would be few registers which we discuss in the upcoming session. Each and every module will have some registers. So you will be passing some instruction to the sensor with the help of wire library, and then the wire library, and then the sensor will return the temperature values. Okay, you need to fetch those values from particular registers. So then the Arduino can access the information. Okay, so this wire.h library is the main thing. So then we have liquid crystal library. This library uses the wire.h library internal functions, and then completely this liquid crystal library operates on wire.h library. So then why use liquid crystal library? It simplifies the things. Okay. So if you want to directly program with wire library, then the program would be very complex and sophisticated. So that's why we will be using liquid crystal library. So now this particular line is used to uh, initialize the library. We are having a LCD function, and it is taking three parameters. The first parameter 0 into 27. It is called as I square C address. Okay. So if you, let's say here we are using 16 into 2 parallel LCD. So each and every module will have an I square C address. So how to identify the I square C address of each and every component? Let's say you are using some other module. Then how can I know what's the I square C address of that module? So that thing tomorrow's topic is performing I square C scanning. Okay. So tomorrow's topic is I square C scanning. Yeah, let me present again. Yeah. So every different module will have different I square C addresses. So tomorrow's concept would be how to perform I square C scan. Okay. And then the first parameter is number of columns, and second parameter is number of rows. So if you just check this design, so it is having total 16 columns and 2 rows. So that's why we have passed the 16 and 2, 16 comma 2 for the LCD function. And then whatever the instructions which are present inside the void loop will get executed for only one time. And whatever the instructions present inside the void loop will get executed indefinitely. So this particular function is used to initialize the LCD module. Without initializing the LCD, if you, despite even you pass these all other instructions, the LCD won't get activated. Okay, so this is the function. Begin function is used to initialize the LCD module. And again, begin function is taking two parameters. First one is number of columns and second one is number of rows. Then this function is used to turn on the backlight. Okay. And then set cursor function is used to set the position from which a particular position the text should start getting printed in the LCD module. Okay. So if I just run this, so welcome to is being printed on the first line and Suchana is being printed on the second line. That is happening only because of the set cursor position. So if you pass 0 comma 0, that will be printed on the first line. So if you pass 0 comma 1, it will be printed on the second line. Okay. So yeah, so this is what we discussed yesterday. So today we will be discussing about wire.h library in detail. So up to here, any questions? Up to here, any questions? I think it's clear, right? Yeah. Somto, is it clear? Yeah. Can you just summarize like what we discussed? Yeah. So you understood about the function. So what's the difference between setup function and loop function? Difference between setup function and loop function. Like here we have a setup function and loop function, right? I'll show you. So this is the setup function and this is the loop function. Yeah. Yeah. So the set of instructions which are defined inside the loop function, they execute continuously. Okay. But whatever the instructions which are defined under the setup functions, they get executed for only one time. Yeah, and Ibrahim is asking the question, are the rows and columns visible on all LCD? Yeah, usually they are visible, okay, on all, usually on each and every module they are visible. You can easily find it. Or else if you don't know how many rows and columns it is having, so there will be something called data sheet, okay. So you can just go to the data sheet as we discussed in the PCB design curriculum as well. So you can just go to the data sheet. There you will find how many number of rows and columns are there on that particular module. Okay. But mostly, if you just observe the module, you can easily recognize the number of rows and columns. Yeah. Yeah. So we discussed that liquid crystal library depends on wire.h library. But now what we are discussing is that even the wire.h library depends upon even low level libraries like TWI library. So TWI refers to two-wire interface. Why it is called as two-wire interface? So if you just go back to the simulation mode, so here you can find the first pin you can see, right? The very first pin, this is the ground pin. Just like just like a battery is having the positive terminal and the negative terminal, this ground pin is something like a negative terminal. But here we call it as the ground. And this is the positive power supply, like 5-volt power supply. And then we are having two wires, right? One is in yellow color, one is in yellow color, and another is in something like a blue color. Okay. So we are having two wires. So that's why it is called as two-wire interface. Okay. So it is called as two-wire interface. So always remember I square C communication. Okay. I square C communication, inter-integrated communication protocol is one of the part of two-wire interface. It's like a one kind of two-wire interface. Why it is two-wire interface? Because whatever the data that you want to transmit from this Arduino Uno to this LCD module, so this entire data transmission will happen only with the help of just two wires. No need of a huge so many wirings, just two wires. So that's why it is called as two-wire interface. Okay. And also remember that I square C operates at different frequency. Okay. I'll show you wire.h library set frequency function. So today I will teach you how to use wire.h library. Okay. So first I'm just removing the entire code. I'm just importing wire.h library. Okay, hash include wire.h. Now I just included the wire.h library, and then I need to start one function void setup. This is like an entry point. So whatever the code inside the setup, they will get executed. It's like an entry point. And then I have void loop. Okay. So right now I'm just leaving it as empty. Okay. Now inside void setup, first we need to begin the wire library. For that we need to type wire.begin. And then we need to set some frequency to the wire library, which we call it as the clock signal. So there are different clock signals as you can see over here. Okay. So these are the different clock frequencies. Okay. So this is one clock frequency 100 kilohertz, and this is 400 kilohertz, and this is 1 megahertz, and this is 3.4 megahertz. So like this, there are multiple frequencies. So why? What's the importance of this frequency? So this is called as clock frequency. So basically, clock frequency determines the rate of exchange of information between a master and a slave. Okay. So if the clock frequency is high, the rate of data transmission, so whatever the data, whether Arduino wants to send it to the sensor, or else sensor wants to send it some data back to the Arduino, all these things happen so quickly. Okay, so clock frequency is very important parameter which actually determines the rate of exchange of information in a two wire interface. Okay, so which is we call it as the clock frequency. So you can choose whatever the clock frequency that you want. So, but most of the people usually set it to 400 kilohertz, okay, which means fast mode. So now I have one question. So now you are operating it something like 3.4, or else, let's say higher frequencies, okay, rather than the standard frequency like a standard mode 100 kilohertz, or else fast mode 400 kilohertz. So let's say you are operating at 3.4 megahertz frequency, okay. So do all sensors, do you think, will be able to support high speed data transmission? Do you think all sensors will be able to support high speed data transmissions? Not necessarily, right? So only few sensors will be able to support high speed data transmission, not all the sensors. So that means whenever you are choosing any kind of clock frequency, then you need to determine whether the clock frequency that you are uh, trying to choose in the particular project, uh, will it be supported by the actual sensor or not. Okay. So you can find this information, what's the maximum clock frequency that the sensor is able to support for data transmission, that will be available in the manufacturer data sheet, or else a manual which will be provided by the sensor. Okay, there you can find the maximum supported I2C clock frequency. So first you need to go through whatever sensor that you're using in the project. First go through the data sheet. There you will find the maximum clock frequency, and make sure that you are using a clock frequency which is very nearer or else equal to the same. Okay. So don't try to use higher clock frequencies. Is that clear? Yeah. So now I'm just putting some. So yeah, we are having different kinds of frequencies. You can use a standard mode, you can use fast mode, but it is always suggested to use something like in medium level rather than going to high speed data communication, because all sensors by default do not support. So you can set it to something like fast mode. Okay, wire dot, and always remember these functions are case sensitive. Okay, so if you just instead of uppercase camel case, if you just type lowercase, then it will return an error. You can click on verify and you can see it will pass an error. Okay, see now it is showing that multiple libraries were found for wire.h library. It is clearly indicating over here that there is some mistake over here. Has no member function. Two wire library has no member function named set clock. So make sure it is already predicted that it should be something like uppercase. Okay, it is very case sensitive. Make sure that you are using. Yeah. So now we have configured the clock signal or else clock frequency. The first step is to initialize the wire library. Okay. This step is to initialize wire library. Only with the help of these wire library, we can perform data transmission. And then we need to configure the clock frequency. Okay. We need to configure the clock frequency. So there are multiple modes, different modes like standard mode, fast mode, ultra fast mode. Like this, we are having different kinds of modes in clock frequencies. Different clock frequencies are available. So now we have set it to 400 kilohertz frequency. You can set it to 100 kilohertz also. Okay, but data transmission would be very small. I mean, very slow. The latency would be very high. So now let's jump into the next part. The first part is to initialize the wire library, and the second part is to configure the clock frequency, right? And then first, before all these things, we need to declare few macros. Macros are something like constants. Okay, macros declaration. Always remember, just after the library imports, then we need to declare the macros. So macros can be defined with the help of hash define. Just like a library is imported with the help of hash include. Similarly, if you want to declare any kind of macros, you need to use hash define. So let's say let's define few things. So LCD address. See, you know about variables and constants, right? Somto, you know about variables and constants, right? Yeah. So here the hash define is used to declare some constants. Okay. Let's say LCD address, which is a constant. For that, we are assigning something value like 0 into 27. Okay. 0 into 27. So Sumto can just tell me why we assign 0 into 27. Any idea why we assign 0 into 27? Yeah. So at least you know what's the meaning of address, I square C address. You know about it? No, right? Okay. I'll tell you. I'll tell you in very short. So there are different, you can connect to multiple sensors with a single microcontroller. Here Arduino Uno is a microcontroller which is containing 18 mega 328p microcontroller. So you can connect as many as sensors that you want. Okay. Now Arduino Uno is receiving information from all the sensors. So the Arduino is able to distinguish whether the data which is coming to it is from particular, let's say sensor A or sensor B. It is able to distinguish only with the help of I2C address. So every module, every sensor will have an I2C address. Okay, every sensor carries an I2C address. Before the actual data transmission happen, before the actual data transmission happen, first the I2C address will be transmitted to the Arduino Uno. Then only the Arduino Uno is able to understand. Let's say, let's take the particular 16 into 2 LCD display. We are calling 16 into 2 because 16 is the number of columns and it is having two rows. So that's why we call it a 16 into 2 LCD library, 16 into 2 LCD module. So as I said earlier, that each and every sensor or module contain a particular I2C address, okay, which is common for, let's say you are buying same 16 into 2 LCD module. So whatever the module of same kind will carry same I2C address. Okay, let's say you are using some other sensor like barometric pressure sensor, then it is having something like 0 into 76 or 0 into 77. Okay, so this I2C address is something like an identification or else a unique identifier to understand to identify the sensor that we are using. So this 0 into 27 tells the wire library that we are using some 16 into 2 or else we are using some LCD module. Okay, is that clear? Somto, is that clear? Yeah. So yeah, in the macros declaration part, first we have declared LCD address 0 into 27, and then we need to declare few other macros as well. Okay. So to declare macros, we need to use hash define. So the first one is rs 0 into 01. I will tell you what is rs and what is en. Okay. And then we need to define en 0 into 04. And then one more thing, hash define backlight 0 into 08. So these are the macros. So nothing but we have assigned some constants, right, to some reference. We have assigned few constants to references. So as of now, you just understand that we have taken some constants like LCD address, RS, EN, and backlight. So I'll tell you more about RS and EN in the upcoming session. So as of now, you need to understand we have taken few constants, macros. Okay. So after this is the library import section. After that, we need to declare some macros. And then inside the void setup, first we need to initialize the wire library. And then we need to configure the clock frequency. And there are multiple clock frequencies. You can choose any one of the clock frequency. So here we have chosen something like a 400 kilohertz as the clock frequency. So yeah, so we will declare few functions. So before this thing, okay, we will declare few functions. So these are the predefined functions, void setup and void loop. So you cannot modify them. It will return and redefinition, redeclaration error. Okay. So now we are defining few more functions like void LCD init. So we are defining these functions over here. Okay. So LCD init and then void LCD command. So first before LCD init, first you need to define void LCD write 4 bits. So this function is also called as send enable function. We discussed yesterday. This function is also called as send enable function. We discussed yesterday about send enable. And then I'm defining one more function, void LCD command. So basically we are having two different functions. This function is to send 4 bits at a time. Okay, 4 bits at a time. It's like a block of 4 bits, block of 4 bits data. And then this function is capable of sending 8 bits at a time. That means 1 byte at a time. 1 byte at a time. Okay. So now, and then we need, yeah. So now I will be telling about LCD 4 bits function. Okay. Are you able to follow? Everyone, are you able to follow? Yeah. I hope my voice is audible, right? Okay, fine. So basically, I just explain very simply. So first we have imported the wire library and then we have defined a few constants. Okay, these all are constants. For each and every constant, we assign some value like 0 into 27, 0 into 01, 0 into 04, 0 into 08. Okay. So why we assigned only these particular values, we will be able to understand in the upcoming session. So we have assigned few constants, and then we have taken two functions. One is LCD write 4 bits function, and another one is LCD command function. And I told you that LCD write 4 bits function is sometimes also called as send enable function. Okay, this function is responsible for sending 4 bits at a time. Okay, and then we have created one more function which is responsible for sending 1 byte at a time. So whenever some data is being transmitted from Arduino Uno to LCD display, that means we are sending data, in the sense we are sending some bits, because all electronic modules can able to understand only zeros and ones, right? So that means we need to send the data in terms of bits. So bits can be sent, first we will be sending 4 bits at a time. Okay, and then we'll be, this LCD write 4-bit function sends first 4 bits to LCD command function, and again next 4 bits again back to LCD command function. This LCD command function gets 4-bit blocks coming from LCD write 4 bits function, and they group two 4-bit data into one single byte, because 8 bits make 1 byte. Okay, and then finally it sends 1 byte data from Arduino Uno to the LCD display function. Then the data will be transmitted. Okay, this is how it works. Is this clear? Yeah. So in tomorrow's session, so as of now, you just understand up to here. So in tomorrow's session, we will be discussing about something called as masking. Okay. So tomorrow's topic is masking. Just remember, come again. So you can just unmute yourself and ask your question, Ibrahim. What's the thing you haven't understood? You can unmute yourself and you can ask. See, Ibrahim, can just tell me 1 byte equal to how many bits? 1 byte equal to how many bits? Any idea? Any idea? 1 byte equal to how many bits? 1 byte equal to, no, 1 byte equal to 8 bits. Okay, not byte. 1 byte equal to not 8 byte. 1 byte equal to 8 bits. Okay, so 8. Let's say you want to print something like A. Let's say you want to print something like A in LCD display. So I told you every character, whatever maybe the letter is, no matter you're printing whatever the data that you want to print, every character is made up of 8 bits. Okay, so we need to send the 8 bits to LCD module. So we have splitted the function. Rather than sending all 8 bits at a time, what we are doing is first we are sending the 4 bits, and again we are sending another 4 bits. Okay, first we are getting first 4 bits, and then again we are getting next 4 bits, and then we are grouping these 4 bits and sending 1 byte at a time. Okay, this LCD write 4-bit function, let's say you want to print letter A. Okay, let's say you want to print letter A on LCD display. So letter A is also made up of bits, right? I'll show you. ASCII to binary bits. So let's say I want to print letter A in LCD module. Okay, then you need to transmit these bits. See how many number of bits are there? Total 8 bits. 0, 1, 1, 0, 0, 0, 0, 1. So total 8 bits are there. Okay. So now what actually we are doing is there is something called masking, which we will discuss tomorrow. Then you will be able to understand complete detail. So we may not be able to extract all 8 bits at a time. First what we will be doing is we are getting first 4 bits and then next 4 bits. So then we will be grouping into 8 bits, and then we are transmitting 1 byte at a time. Is that clear? So let's say you want to transmit letter A, you want to print letter A in the LCD display. Okay. So if you want to print letter A, what you need to do? You need to send all 8 bits to the LCD module. Then only it will be able to print letter A in the LCD display. So in order to send all these 8 bits at a time, so first what we need to do is we are extracting the first 4 bits, and then we are extracting the next 4 bits, because it's not that much easy to extract all the 8 bits at a time. Okay. So we are using some technique. So through the technique, we will be extracting first 4 bits at a time and then extracting the next 4 bits at a time. So the first function we declared over here, LCD write 4 bits. This function is to extract, is to convert whatever the character that we are passing. Let's say we are passing letter A. The main function, the main role, responsibility of this LCD write 4 bits function is to extract first 4 bits and then extract the next 4 bits. Okay. So basically it is splitting the from a character, it is obtaining the first 4 bits and then next 4 bits. So totally we are obtaining 8 bits, right? So now this function, LCD command, this function is responsible to merge the 4 bits coming from send write 4 bits function. So if you pass, let's say you passed the letter A to write for 4-bit function. So first it will extract the first 4 bits and send it to LCD command function. It stores the first 4 bits, and then again the next 4 bits that will be sent by the write 4 bits function. It will be passed through the LCD command function. So already it is having the first 4 bits, and then now we got the second 4 bits. Now we will be merging first 4 bits and second 4 bits. Total we are getting 8 bits. So 8 bits make 1 byte. 1 byte means one character. That means letter A. Now this A will be sent to the LCD module in the form of bits, 8 bits. That means 1 byte. Okay. Is that clear? Yeah. Shikarani, are you there in the session? Yeah, I think she was busy right now. Okay. So Ibrahim, now you understood, right? Okay, fine. So tomorrow we will be discussing how to extract first 4 bits and second 4 bits, because see always if data transmission is occurring, if you are printing some text on LCD display, the data is being transmitted in the form of bits. So now the question is how to extract from any character, how to extract the bits, because only if you are able to understand how to extract bits from let's say if I suddenly give you letter B. Now I told you to if I ask you what are the bits, 8 bits. So now you will be able to tell the entire bit. So tomorrow we'll be discussing the mathematical strategies to determine the bits of any character. Okay, is that clear? Tomorrow we'll be discussing two important things. The first thing is some tricks and strategies, to determine the bits of the bit sequences, the 8-bit sequence of any character with the help of some mathematical analogy, or else with the help of some other strategies. Okay. And then second part is there is something called bit masking. Bit masking. So tomorrow we'll be discussing about how to get the bit sequence, 8-bit sequence from any character, and how to do bit masking. These two concepts we will be discussing in the tomorrow's session. So as of now, you need to understand only the thing like, so first we are importing the wire.h library, and then we are storing some constants, which we call it as the macro section. And then we are having two functions, setup function and loop function. Whatever the instructions inside the setup function executed for only once, and whatever inside the loop function get executed continuously. And inside the setup function, we have used two things. What is one is wire.begin, and another one is wire.setClock. So wire.begin is to initialize if you want to do any kind of communication, if you want to send some data. So to do whatever you want to enable the data transmission, first you need to initialize the wire library. So that's why we are using wire.begin. And the second thing is wire.setClock. So setClock is something which determines the rate of exchange of information. So wire.begin is to start data transmission. Okay, is to start the transmission. Whenever you place the particular line wire.begin, then only the both modules will be able to communicate. So in the second step, you are configuring the rate of flow of information. So there are different frequencies like 100 kilohertz, 400 kilohertz, right? Standard mode, fast mode, ultra fast mode. Like this, we are having different modes. Okay, for different kinds of frequencies. So the here we are configuring the clock frequency. The clock frequency is something which determines how fast the data to be transmitted between the master and the slave in the I2C protocol. Okay. And we also discussed that I2C protocol is called as two-wire interface, because whatever the information that is being exchanged is only with the help of two wirings. First one is serial data and another one is serial clock. Okay. And then we have declared one function called LCD write 4 bits function, or else we also call it a send enable function. And then we have one more function called LCD command function. So command function is to send some commands to LCD module. Okay. And LCD 4 bits is to extract first 4 bits and then the last 4 bits. So basically this send enable function, or else we can also call it a send enable function. Basically this send enable function is to extract the bits from any character. Let's say you want to print a letter A. I already shown you the bits of the bit sequence, the 8-bit sequence of letter A, right? So first we need to extract the bits. Then we can pass. Then we can send the data in the form of bits. Then the module will display as letter A. So that means we need to send the bits. So to extract the bits from any character, there is something called bit masking. Okay, there is some technique called bit masking, which we'll be discussing tomorrow. So as of now, you need to understand sendable function is responsible for first extracting the first 4 bits and sending the first 4 bits as one block, and then it starts extracting the next 4 bits, and it sends one more block of 4 bits. These first 4 bits block and second 4 bits block will be sent to send command function. And send command function is the place where actual these bit merging is happening. First 4 bits is merged with the second 4 bits, and finally we obtained 8-bit sequence, which makes 1 byte. That means one character. Now these 8 bits are sent to the LCD module. So if these 8 bits are sent to the LCD module, then the letter A will be printed on the LCD display. Is this clear? Yeah. You have any questions, Ibrahim, before I end the session? Okay, fine. I hope today's session is informative. This is Hemant from Suchana signing off. Bye bye.